Welcome to our class, and our topic is about related rates. Introducing our members.
Hi, my name is BAKHTIAR bin SUHAIME. My number ID is 2022-840-936.
Hi, I am Muhammad bin YAHYA. My student ID is 2022-606-152.
I'm HISYAM bin Abdul Malik. My student ID is 2022-620-368, and we are from group 21.
Before we start, let me give you a short introduction about related rates. Problems involving related rates require two or more variables that change simultaneously, possibly at a different rate. The rate of change is usually with respect to time. What is differentiate? Differentiate is a method of finding the derivative or rate of change of a function. The rate of change of function is defined as dy over dx equals to fx equals to y. The objective for this assignment is to calculating the rate of change of one quantity in terms of the rate of change of another. Perhaps more easily measurable, quantity is the principle behind a related rates problem. The procedure is to find an equation that relates the two quantities and then use the chain rule method or implicit method.
To solve a question involving related rates, you can follow these general steps. First, read the problem carefully. Understand the scenario and what quantities are changing with respect to time. Identify the given information and what you're trying to find. Second, identify the variables. Determine the variables involved in the problem and assign appropriate symbols to represent them. Typically, there will be at least two variables that are changing, such as the rate at which one quantity is changing and the rate at which another related quantity is changing. Third, write down the given information. Note down all the relevant information given in the problem statement. This could include the values of certain variables, any known rates of change, or specific relationship between variables. Establish an equation. Formulate an equation that expresses the relationship between the variables in the problem. This equation can be derived from the problem statement or from known mathematical principle. And 5. Differentiate the equation with respect to time. Take the derivative of both sides of the equation with respect to time, often denoted as dt, using the chain rule. These steps involve differentiating each term in the equation and multiplying it by derivative of the corresponding variables with respect to time.
Number 6. Substitute known values. Substitute the known values into the derived equation. This step helps to eliminate any variables or rates that are known or given in the problem. Number 7. Solve for the desired rate. Rearrange the equation and solve for the rate you are trying to find. This may involve isolating the desired rate variable on one side of the equation and all other variables and rates on the other side. Number 8. Substitute back and evaluate. Once you have obtained the expression for the desired rate, substitute the known values back into the equation to calculate the actual numerical value. Last step, check your answer. Verify that your solution is reasonable and satisfies any given conditions or constraints in the problem. Review the units of measurement and ensure they align with the problem's requirement. Make sure your answer is carefully double-checked.
Problem statement is to find the rate of water level rising inside the cylinder tank in the minute.
Hey, Afi, can you help me with this question?
What was going on? Oh, I also trying this question right now. How about we search together?
But how? Our question is, a cylindrical tank is being filled with water at a constant rate at 5 cubic meters per minute. The tank has a height of 10 meters and a radius of 4 meters. At what rate is the water level rising when the water is 6 meters deep?
Hi guys, now I will show you how to solve this question. Okay, the question asks to us to find the rate is the water level rising when the water is 6 meter deep. Okay. To find the rate at which the water level is rising when the water is 6 meter deep, we can use the formula for the volume of a cylinder. V equal to pi r square h, where V is the volume, r is the radius, and h is the head. Given that the rate at which the tank is being filled is constant at 5 cubic meter per minute, we can differentiate the volume equation with respect to time. dV over dt. So dV over dt equal to d pi r square h over dt. To find the head is changing, we need to find an expression for dH over dt using the given information. Okay, the given information is, we know the radius is constant at 4 meter. To find an expression for dH over dt, we can differentiate the volume equation with respect to time using the chain rule.
The related rate technique is an application of the chain rule. We use this technique when we have either three variables. We may want the rate of change of one variable with respect to minutes, like our question, and those variables may be connected through equation using a third variable.
dV over dt equal to d by r square h over dt. So we get the pi 2rh dh over dt.
To make it easier for us to solve this equation, we have to draw first the cylindrical tank, which is the height of the cylindrical tank is 10 meters, the radius of this cylindrical tank is 4, and the water level of this cylindrical tank is 5. Now, we can substitute the non-values into the equation. When the water is 6 meters deep, the height h is 6 meters, the radius r is 4 meters. 5 equal to pi 2 multiplied by 4 multiplied by 6 dH over dt. Now, simplifying the equation, 5 equals to 48.5 dH over dt. And now, we will solve for the dH over dt. This we get dH over dt is 5 over 48.5. And the answer is 0.033 meters per minute.
Conclusion. Thus, if we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing.